Hey beautiful people, welcome back to my channel. My name is Busisiwe Dlamini Harodi, the campus principal. So today we are going to do preparing of solutions. I think the preparing of solutions topic, we're going to do it in a couple of series. Follow me and then we should be able to get right with it. So basically what we're going to do before we can start doing other things is to define a few words that we will talk about every now and then when we speak about solutions. So the first way to define it will be, what is this? What is a solution? What are we talking about when we talk about a solution? So basically a solution is a mixture of two or more substances. So when you mix things, you're mixing your tea with water, coffee with water, and so on. So basically what you'll be doing, you'll be preparing a solution. And the next word now, it will be, what is a solute? Because your solution, it comprises of solutes and a solvent. So basically what a solute is, a solute will be that substance that it will be dissolved by a solvent. Thinking about it, to be able to get an example, if you can think about salt and water, so when you mix salt into water, so then that salt will become a solute, because that salt is what it will be dissolved by the water, which takes us to the definition of a solvent. So what a solvent is a substance that will dissolve a solute. So in our example of salt and water, so it means salt will be the solute and water will be the solvent. And then as well, there's also two types of substances that we can talk about in chemistry. There's what we call miscible substances and immiscible substances. So basically what immiscible substances are, those substances that even if you can combine them, you can never get a solution out of them. You can try, no matter how hard you can try to mix them, they will never ever come to being a solution. So those are the immiscible substances. An example that I can give to, it's like oil and water. No matter how much you can try to mix oil and water, they will never mix. At the end of the day, once you leave them there, they will separate into their own the way they are at the end of the day. So there's no way you can be able to mix those two. So those two substances, we call them immiscible. So you can't mix. And then miscible substances, it will be those substances that when you mix them, they can be able to give you a solution. Going back to our example, when we did the solute and the solvent, so salt and water, they are miscible substances, because when you mix them, they become a solution, which it can be a sodium chloride solution. Then going back to solutions, so there are two types of solutions that we can get. There's what we call homogeneous solutions, and there's what we call heterogeneous solutions. So with homogeneous, this word homo meaning the same. So basically what happens is that when you mix these, when you mix substances, what happens, you end up having a uniform solution. So that is a homogeneous solution. But whereas with a heterogeneous solution, when you mix the substances, you end up, what you will get a solution that is not uniform. So now, since we have defined the few words that we usually get when we talk about solutions. So what happens, like in the lab, every now and then we find ourselves mixing stuff, trying to make solutions. Those solutions can either be reagents, they can either be QCs, they can either be detergents, and so on. So we usually prepare those things at them almost every day at regular basis. So, but then what usually happens is that we don't just prepare a solution. We prepare a solution by checking the correct concentration that we need of that specific solution. So the concentration matters, because you find that the solution will be effective for certain things at a specific concentration. So we need to be able to take that into consideration. So I'm going to wipe the board, and then we will discuss the different ways in which concentrations can be expressed. Okay, so concentration can be expressed in 3 ways or even more. But what we will do, we'll discuss more into details these few that I'm going to give to you. So concentrations can be expressed as a percentage. It can also be expressed as a weight over volume. And it can also be expressed as a volume over volume. And lastly, from what we'll discuss, it can be expressed as in moles. So for now, for this video, we're going to discuss these 3 first, and then the moles you will see as we go along into the other series. So basically, what do I mean when I say the concentration can be expressed in percentage? Okay, we can take an example of what is going around in the world with this COVID-19 situation. We are being told that we must make sure that we have a sanitizer that has a 70% alcohol concentration. So basically, that's what it means. Means the concentration of alcohol in that sanitizer that you have, it must be 70%. But basically, what does that mean? Basically, what it means is that, as we know that a 70% is the same as 70 over 100. And because we are talking about alcohol, then it means this 70 would be 70 milliliters. And then this 100 basically, which is your total volume, will also be in mils. So like I said, the 100 represents the total volume, and the 70 ml will represent your solute, which is what will be dissolved by your water. So it means if you were to prepare 100 ml 70% alcohol sanitizer, it means what you are going to do, you are going to add 70 mils of alcohol, that alcohol that you'll be using, and then you will top it up to 100 mils, because your total volume is supposed to be 100 mils, and then that's what the percentage would be. So this example that I've just given to you, it is a volume over volume example, because volume, we are talking about mils over mils. So it means now, because we are speaking about a liquid and a liquid, so that is why at the end of the day we top it up. But you will understand as we start doing the calculations in the next video sooner. Again, what can happen when we talk about weight over volume, it's when now you are mixing a solid with a liquid. So let's say we're talking about 20% sodium hydroxide solution. So basically, what does this mean? It means 20 over 100, if you remember. Then, because sodium hydroxide is a solid, so it means your 20 will be in grams and your total volume will be in mils, because we are talking about a solution at the end of the day. So it means to make a 20% sodium hydroxide solution, if you were to make 100 ml, if the only volume that you need to be able to carry your task on that specific day, you need 100 ml. It means you are going to dissolve 20 grams of sodium hydroxide into 100 ml of distilled water. I'm sure you can see the difference. With the volume over volume, we top up. But with the weight over volume, what do? We dissolve, because it's a solid. So basically for today, this is actually where I would like us to end. Make sure that you keep in mind what does this 20% means for both weight over weight and also for a volume over volume, so that when we come back with the next video, you can be able to follow when we start to doing actual calculations. So thank you very much. That's it from me today. Please do not forget to subscribe, like, and share. And also make sure that you become interactive. Ask me any questions that you want, any clarity. And if you need more or extensive help in preparing for your board exam, make sure that you contact me on my email address. I would gladly be able to help you. Thank you.